Okay, starting on today. So today we cover a lot of algebra in one setting. Okay, just a system, that means your system has only x to the first power in it, like both of those there. And you did this a lot in algebra. Those of you who joined us this summer, we did systems a bit. Okay, these brackets sometimes hold our systems together. So this chapter we're going to study systems with two variables, x and y, and then systems with three variables of x, y, and z. Okay, so the two variables is our quick review to make sure we have it down, so that then at the end of the chapter, when we get to the three variable systems and we're graphing in coordinate space, it makes it a little easier. A solution to a system is a set of values for the variables that makes the equation true. Okay, so those are our definitions there. I'll give you another minute or so to kind of copy whatever you want down from there. Okay, and then we're going to talk about question 1 and 2. It says, examine the slopes and the y-intercepts of the linear equations in the system above. Will these graphs ever intersect? Go ahead and tell your neighbor what you think. Yes, no, and why or why not? Hey, how many say yes? Okay, go ahead and tell your neighbors where they're going to intersect. They will intersect. Where?
I don't care. I should.
All right, volunteer. Jocelyn.
Will they intersect at 0, 3 because one of them is a negative slope and one of them is a positive slope, so they will have the same y-intercept.
Okay, good. I'm going to focus in on that y-intercept. They both have the same y-intercept, so they're going to intersect at that y-intercept. Okay, how many different points of intersection can a line have? Chase or Chan? What's that? One. Okay, so Chan says one. Everyone agree? Yes. Two lines can have at most 1 point of intersection. Okay, two lines can have at most 1 point of intersection. So if, for instance, these two lines happen to be the two lines that we were talking about here. So if this is our x-axis, this is our y-axis. If this line right here is y equals x plus 3, and this line right here is y equals negative 2x plus 3, they intersect right there at 3 on the y-axis. So our solution is 0, 3. Okay? And we could always test that solution, right? We could plug that in here. We could plug in 0 for x and see if we get 3 out for y, and we do. 0 plus 3 is 3. And put 0 in here. That's 0 plus 3 is 3. Okay? So that's our solution. Now, two distinct lines can have only 1 point of intersection. However, if I were to think of, say, like, we know what one solution looks like. When could I have a situation where there's no solution? One person? A couple of yous? Okay, go ahead and tell your neighbor what you think. What's one solution? All right, Eli, what do you think? Okay, if we got parallel lines, so in equation form, Palmer, what does that mean? Good, they have the same slope, possibly y equals 2x plus 4 and y equals 2x plus 6. Good job. Same slope, different y-intercept. Lines are parallel. That gives you a no solution. They'll never cross. So if you remember your markings from geometry, there's our parallel symbols. Okay? Infinitely many. Now that begs to differ. Going back to this, we said that there could only be one solution. Now I'm saying there could be infinitely many solutions. When do I have infinitely many solutions? Maddie?
When it's the same line?
Yeah, when it's the same line. So I said we have one solution when we have two distinct lines, and that's what Chance was talking about there. Okay? But if we have the exact same line, for instance, y equals 4x plus 3 and y equals 4x plus 3. Now usually the book won't, like when you see in this, they won't give you this. They'll maybe get tricky with you and say, well, we're actually having you do y minus 3 is equal to 4x. And then you put it in slope-intercept form, you see that it's this, and you're like, oh, they're just being tricky. That's infinitely many. All right? So if it's the same line, it's infinitely many. Same line means same slope, same y-intercept. All right. Any questions there? How many remember all this? Good to go so far. Okay. I want you to try number 2 there. Work together. Use your original equations, please, when you're completing it. Use these original equations to complete number 2. It's on page 150 for those of you trying to follow along. Okay, so the way we verify it, how do we verify? Go ahead, Cody.
You plug in the coordinates in so that the first coordinate x is x in the equation, and then the second coordinate y is the y in the equation.
Good, so you just plug those coordinates into each one, make sure that they give you true statements. So when I put -3 in, so I get -3 plus 2 times -2. See if that equals 7. In this case, -3 minus 4, that equals -7. So we're good. Okay, we try the same thing here. 2 times -3 plus -3 times -2 equals 0. -6 plus, it's a positive 6 there. That equals 0, so we're good. It has to be true in both of them. That means it's a solution. Okay, that's where we're at with those. I want to try using our graphing calculator with it. But before we do that, any other questions on this? Okay, you need a graphing calculator. I want you to plug in number 6a into your graphing calculator. 6a. All right, for those of you putting this into your calculator, make sure when you put 2x plus 3, okay, in your y sub 1, and then in your y sub 2, when you put -x, make sure you're using the negative symbol down here, not the minus sign. Okay, we hit graph, okay, and we see these points of intersection. All right, how do we calculate that point of intersection? Have we talked about that this year?
Yes.
All right, how do we do it? You remember, Lucas?
You press second trace,
Okay, go second trace.
then you go down to 5, which is intersect,
Good. Go down to number 5, intersect, or hit number 5.
and then you just hit enter until it gives you the intersect.
Good. And you can hit enter 3 times here. It's asking you questions, but since we only have 2 lines in our y equals menu, it says first curve, do you want it to be y sub 1? And we're like, yep. Second curve, do you want it to be that? Yep. And remember, they call them curves because most of our graphs are curves. It just happens we're working with linear. Okay, this one says guess, but since there's only one point of intersection, you don't even have to do anything. You just hit enter. If there are multiple points, you would have to put your cursor next to the point you wanted to calculate. So we hit enter. The solution is 2, 7. Ordered pair form, x, y, 2, 7. That is our solution. That means if x is 2, 4 plus 3, that gives us 7. We're good there. -2 plus 9 is 7. We're good there. Okay? Now, in order to use your graphing calculator, you really need to be in what form?
Wait,
Yeah, to use your graphing calculator, notice it's y equals mx plus b form. So on letter B, what are we going to have to do here? Yeah. Why don't you guys go ahead and graph those there. Okay, get my -4x in there. This one I have to change around, so I'm going to go ahead and subtract my 3x. Okay, so we get -2y is equal to -3x plus 11. Divide by -2. Make sure you divide each term by -2. So you get y equals +3/2 x minus 11/2. So some students wonder how they put the fraction into their calculator. I just use the division symbol. So 3 divided by 2x. For those of you that want to, there's an actual fraction button. If you go to math, y equals in the newer calculators, and you could use that to put your fraction in. So yeah, you could use 11 over 2 if you have to see it like that. It really doesn't matter, but then we hit graph. Okay. Any questions up to there? Calculate. 5, enter, enter, enter. And the solution is 1, negative 4. So x is 1, y is negative 4. All right. But answer these questions really quick with your neighbors. Just answer number 13 with your neighbor. Group, parallel lines, number of solutions.
None.
0. Intersecting lines.
1.
Same line.
Infinitely many.
Infinitely many. No, I'm not using the infinity sign.
Put a whole Bible.
That means infinity. Equal slopes for parallel lines, yes or no?
Yes.
Yeah.
Intersecting lines.
No. Yes.
No.
No, otherwise they'd be parallel. Same line.
Yes.
Yes, well if same line and parallel lines have the same slope, how do we know that one's no solution and one's infinitely many solutions?
From their y.
Y-intercept.
Good. Y-intercept. Parallel lines have the same y-intercept?
No.
No.
Yes.
Infinitely many does. Okay. Any questions there? That's a very quick review of dealing with systems. All right. A quick notation I want to point out is number 15. You won't see it much this year, but you will see it in upcoming years. The notation, this notation right here, you'll write answers like that. You'll see that as a solution. Okay? This says the set of ordered pairs x, y such that y equals 2x plus 3. In other words, this says infinitely many solutions. It says the solution set is every ordered pair of x and y that lie on this line. That's what that says. Every ordered pair for x and y that lie on this line. And then this actually says which one up here is that? Well, we know it has to have a y equals 2x plus 3. Is it this one? All of these solutions lie on y equals 2x plus 3. How about these solutions? No, these solutions lie on y equals 2x plus 1. They'd have one solution in common. Okay? Well, these do. Do these? Reduce your equation by dividing by a common factor. That gives me negative 2x plus y equals 3. Move the 2x over, I get y equals 2x plus 3. They both are y equals 2x plus 3. That's your infinitely many. That's your solution for letter B. Okay, now we won't touch on that this year after this in terms of that notation, but just so you know, okay? So you've been introduced to the notation of it. Okay, I want to try some problems together. The group, you have some grids. These are right off your assignment today. So this is example 1, number 1, you're going to put them in your notes. I want you to try 1 and 6 together, your groupies.
Hey, group.
Okay, so I'm going to graph this one right here. Okay, go down to negative 3 in the y-intercept there. Go up 2 over 1. Oops, messed up on that point. So we'll ignore that point. Okay. And we've got it. All right. Now this one, if you want to use x and y intercepts, when x is 0, we put 0 in for x, we solve for y, y is 3. Okay, and so maybe we use a different color here. When y is 0, we put 0 in for x, or for y and solve for x, x is 3. So those are 2 points. 2 points would make a line. You could actually see your slope in there as well. And so when you're, did I mess up right here? Minus 2. Oh, I did. That's supposed to be a point right there. I really messed up on my points there. All right, I'm going to have to graph that one again. That one's ridiculous.